Thank you very much, Joseph. And yeah, it's definitely a pleasure being here. And thanks so much for extending the invite, Joseph, as well as Andrew. And I think I owe Andrew quite a bit. Our meeting in Cape Town, is purely coincidental, but it opened up quite a bit of opportunities to meet everyone and be involved, with others all over the country. Well, not only the country, but the continent as well. And I'm appreciative for that meeting, Andrew. Um, so I'm going to start sharing, and we can take it from there. Okay. Joseph, is that fine? Perfect. Okay. Thank you very much for making the time, everyone. It's a brief outline of what we're going to cover. And just in terms of an introduction to myself, the space, what's the vision of the lab, and then we're going to talk a bit about research and innovation in the higher education space, and as well as the role of makerspaces in higher education. And then briefly, if we have some time, some of the services that we offer and activities to address, the need and the critical role that makerspaces play in higher education. And if we have some time, maybe just touch on some of the projects that I've been involved in, which range from undergrad projects all the way through to professors and research staff working on projects. And then we're going to touch a bit on the challenges with makerspaces in higher education and maybe a few takeaways in terms of some of the key learnings that I have experienced and I have taken away over this period, and perhaps some of the future goals and objectives of the space. And I'm just going to switch off my camera because of just to ensure that the connection is clear. So, in terms of my background, I'm a mechanical engineer. I've had experiences being an academic, a designer, and I'm currently obviously managing the Menzi Design Lab, which is based at the University of Cape Town. And we'll touch briefly on what the vision is for the Menzi Design Lab. I've spent the past, well, over a decade in higher education in some form. I was previously an academic lecturing engineering design as well as other courses. I spent some time prior to my appointment at UCT managing 5 makerspaces in South Africa and growing them and building it at my previous employer. And I've been basically at these 3 different institutes in some form or capacity, including Durban University of Technology, Regent Business School, and now the University of Cape Town. So as I said, UCT, for those of you that have visited us in Cape Town, we based at the bottom of the mountain, and it's a lovely location and beautiful university. And I think we currently ranked #1 in Africa. Uh, so in terms of the Menzi Design Lab, this is a shot of where the lab is and where is it located. Coincidentally, it's located in the Menzies building on upper campus at UCT. And in terms of the actual Menzi Design Lab, they took inspiration from the word Menzi, which in Xhosa refers to makers. And the lab itself is envisioned to grow over a period of time to provide a world-class design and production environment for students, staff members, researchers to basically develop and prototype ideas that sit outside the curriculum. So in terms of the university environment, it's very traditional, very siloed, and you don't necessarily have the opportunity to work on projects that are outside your field of study or your field of research. So we're trying to offer a facility in terms of a makerspace or an academic makerspace where you can develop these IPs and products and prototype. It could be something like even solving a community need, or you could, from the onset, be looking to commercialize a product and have an idea in mind that you've been working on. And we can assist in terms of the entire process from building of the prototype all the way through to hopefully commercialization and then a spin out company. So it it's meant to serve the entire UCT community, but that doesn't mean that we don't interact with other makerspaces as well as other individuals within the wider community. We do involve ourselves in other projects and in um, other trainings, etc., that are within the community and to serve the community. but our direction is majority of the time is spent on developing these ideas at UCT. And just to maybe give an idea of research and innovation and how it works in higher education and what's the need for a space, because research is constantly ongoing within higher education and it is happening, but it is actually siloed. So I think the easiest way to look at it is in terms of what we call the technology readiness levels, which is used internationally to basically classify the level at which a product or an idea is. And you'll notice that it goes from TRL1 all the way to TRL9. And in terms of the higher education environment, you have what we generally refer to as the Technology Transfer Office, which in UCT's case is called Research Contracts and Innovation, but it's effectively the Tech Transfer Office. And the purpose of this office is essentially to take research that can be commercialized and effectively take that research, commercialize it, if it means a spin-out company or it means licensing the technology, etc., and make effectively money off it to make it sustainable for the university, as well as to protect the IP that's generated from research. So they work in terms of research departments and academics, and they work from TRL3 effectively all the way up to 9. And essentially, the challenge here is that in higher education, that means that you require access to a research lab, an academic, and generally prior work or prior experience. Because what this means, for example, if someone wants to specialize or develop something in robotics, you will have to do a master's in robotics at perhaps the African Robotics Unit at UCT. Or if you want to do something that's in biomedical engineering and develop a device, you have to get access to the master's program in biomedical engineering, which means that it's at a higher level versus your undergrad students. And it also means that you need access to the research lab, you need an academic on board to support that project, and you need prior knowledge and experience. So this means that anyone that has an idea that's not maybe on that level, or anyone that's in the undergraduate space, or even a staff member that doesn't have access to a research lab, effectively can't research or innovate or develop their idea because they don't have access to those facilities. So this was identified as a need to cater to those that are in TRL 2 and 3, where ideas have just been generated and where students and staff members can actually work on these ideas and hopefully build them up to TRL 3, 4, 5, etc., where they become much more larger projects and then they can access funding. Because as it stands, you can't access funding at UCT or generally in higher education until something is proven innovative and is already on TRL 3 or 4, which makes it quite challenging for people that have ideas and don't have the facilities. So we're looking at, in terms of TRL 1, 2, and 3, as a space that needs to basically be nurtured to ensure this pipeline of innovation at the university. So this is the space effectively where the Menzi Design Lab plays in, and that's kind of our role, in that we look at ideas, concepts, even sometimes a proof of concept or a small rudimentary prototype, etc. And we try to see how we can assist to take it further. And then if it does go between, if it does progress from one level to the next, we continue to follow the process. So in some cases, we go all the way to the end of the process to commercialization, etc., which we are currently in progress with one or two of our projects. But we also allow for a space where students can come in, where staff members can come in and bounce ideas off us, and we can look to see how can we validate this, what research needs to be done, what resources can be allocated. So we effectively trying to fill that gap. And with that, there's obviously a number of challenges which I will discuss later. So that's the space we play in, and that's kind of generally in South Africa, I can speak for the South African context, the challenge in higher education, because research is generally done at a higher level and it requires more funding, it requires prior knowledge, as I mentioned, and it eliminates a large portion of ideas and doesn't allow for students and staff members to have a place to create. So in terms of why this is important and, the critical role that makerspaces play in higher education, I think if we were to just list a few things, and I'm sure there's more than this, but at minimum, a makerspace in higher education plays a role of exposure. So exposing students and staff members to technology, to products, to innovation, etc., which can at least pique their interest. Perhaps someone may not be interested in really learning about 3D printing, but or actually using a 3D printer, but they may realize that, listen, 3D printing now has applications in industry, in business, etc. So that exposure leads to knowledge, which leads to them having an understanding of what's actually happening in the real world. And then, as I mentioned, fostering an environment for creation is very important, because what tends to happen, and we've noticed this over the time I've been in higher education, is that if students and staff members don't have facilities or labs that are open to them, what tends to happen is they effectively have this great idea, but there's no one to help them. So they lose enthusiasm. And unfortunately, we're losing a lot of good ideas, as well as passionate students and staff members, to the fact that we don't have facilities for them. So fostering an environment of creation, ideation, building, iteration, etc., is very important at this stage. And then taking those ideas into action. So how do we take those ideas, tangibly build some sort of prototype, and then take it up to the next level? And then it also serves to encourage entrepreneurship, because, and I mean, we know even throughout Africa and South Africa especially, unemployment is a significant challenge. And if we can encourage entrepreneurship, and if students have the opportunity to develop these products and maybe even have spin out companies, they could then go into entrepreneurship. They could employ their friends, they could employ colleagues, etc. And that will allow for entrepreneurship and employment. And promoting skills development, I think this has become quite important, especially in the context of higher education, where a lot of the traditional skills development, even I can speak for engineering, where you spend time in the workshop, you use machinery, etc., has been slowly removed from the curriculum. An example of this is perhaps manual drawing. So when I was a student studying mechanical engineering, we had to do manual drawing, and you had to physically use pencil, T-square, etc., and yet you had to do manual drawings. Nowadays, majority of the universities, unfortunately, has removed manual drawing and replaced it completely with CAD. So we would do manual drawing, and then we'd graduate to CAD, for example. And by removing those skills, you're removing a tangible element of a university graduate's or university students' experience, where they get to work with their hands, they get to be creative, they get to not necessarily make, but use their hands and create something. And we're trying to promote skills development, whether it's through the machinery that we use, through the projects that are built, etc., where they can tangibly work on something. And it's very easy to design on paper, but when it comes to actually building something, that's when you realize what the mistakes were and what the assumptions were during the design process. And if they're not exposed to that at university, when they go out into industry, unfortunately, it's going to be a rude awakening for them. So I think skills development is very important, and enhancing the university experience as well by allowing them exposure to multiple different technologies, multiple different individuals as well. I mean, makerspaces attract a variety of people who have varying backgrounds and experiences, and that can help to shape the university experience and the exchange of knowledge. And then developing graduate attributes. And this is something that has actually been one of the very big positives that have come out, in that when students graduate, or even when they're looking for internships while they are still at university, a common question they've been asked is, what else have you done? So you've got so many thousands of students applying, hundreds of students applying for an internship, etc. They all may be getting good marks in class, but what differentiates you? What graduate attribute do you have that makes you different from someone else? And we've got proven case studies of this, where a student of mine that had come through to build his own drone and drone delivery device as a side project in the lab actually got into, I think, 2 internships over the holidays. One, I think, is in the AI field as well, based on the fact that he had done these mini projects while he's a third-year student, and he'd dabbled and built his own drone, etc. They weren't concerned about the marks and what degree you were registered for, but more concerned about the fact that you've actually made something, you've built something, and it's not just theoretical knowledge. So we're seeing, a need for that. And if you look at the 21st century skills that employers are always looking for, the makerspaces are definitely a platform to build those skills and make our graduates and our students much more all-rounded and contribute to their CVs in a meaningful way. Um, so with regards to how do we do this and how does this tie into what the Menzi Design Lab does in terms of its services? Uh, so in terms of our services and activities, the most common one is prototyping services that we do for design and manufacturing. And this can be in terms of assisting startups, researchers, students, all the way from undergraduate through to professors, and even in some cases, alumni that have come back and they want to work on a project with us. And the idea is that we offer the facilities to consult with them, to give them design guidance, to basically to 3D print, and to help them along the process. In some cases, we even sort of design the entire pipeline and what should be expected if a project or product needs to go all the way through to commercialization. And I think one of our big successes was with the indigenous games, which was a collaboration between the Menzi Design Lab and the School of Education, where a professor came up with games that are inspired by indigenous African games that he played when he was growing up. And we've since started prototyping them. The lab has had a significant contribution in building the components, designing the components, and we've actually now secured 2 provisional patents for this. So officially from this month, I'm a patent holder, which has been quite exciting, and a co-inventor on this project. And that's the first patent that the Menzi Design Lab has actually secured. So I'd love to share more details about this, and hopefully we can do this at another time, because it's currently in the registration phase and with the patent phase. But effectively, it was a collaboration across multiple departments. So we had the School of Education, the Menzi Design Lab, as well as RCNI, which is the Research Contracts and Innovation Office. And then we even had one of our colleagues here who runs a print farm in Cape Town to actually print the first test batches that are going out for testing just before the commercialization step. So it's been it's been wonderful to see the whole pipeline actually work, and we're heading now towards commercialization and developing this into a full product. And in terms of other activities is incubation of early stage startups. So here it's just before they can actually get funding at the university through RCNI. So your technology readiness levels at a lower level. And one of the significant projects that has come out from this is a Wi-Fi chip, which is a group of they've qualified now as master's students, and they were students when they first started this project, and we provided the resources for them to meet. We linked them with the academics that could allow them then expert advice. We also helped link them with industry partners like Siemens, etc. Because the development of this was accelerated very quickly, the project actually outgrew our lab, which sometimes sounds counterintuitive, but the faster a project outgrows our lab, the better for us and the better for the ecosystem, because that means we've gone through MVP and the product is growing, the students are benefiting, and it's now moving on to commercialization. And in this case, this project actually moved quite quickly through the processes, and they're now trying for commercialization, but because of the nature of the project, it may take another year or two. And they're currently raising, I think, the 5 million rand required to take it to the next step. So incubation of these early startups is quite important, because that then allows you access to other resources at the university or external resources. And then in some cases, we work on things where it's high risk, where it's experimental, it's interdisciplinary, and where there aren't typical homes for these or typical departmental structures where these projects can be actually housed. And one of the projects we're working on and we'll continue to work on, especially in 2026, is experimenting with fusing 3D printing with art in the art department. So these are not things that are normally done within the art space, for example, but we have the space that can experiment with this. And if it succeeds, it succeeds. If not, we try again, So it allows us to take on these projects that are not typical in your current traditional structures in a university. And the other thing that we're slowly moving into is specialized skills training. And these are things like where companies give beneficial training to students and staff that will help them either in their job or as a graduate. And we're experimenting with some including maybe doing some automation with Siemens, etc. But we haven't done any of these as yet. It's all in the sort of the ideation and the planning stage. And then in terms of the general, the makerspace additional services, we also offer design and manufacturing support for student competitions. So multiple students have taken part in instructable competitions where they've won competitions. We've got the Cars for Mars project, which is a rover project, the Formula Student Africa project, and there's multiple projects that aren't housed in traditional environments at the university, which we take on and we assist. And then there's training in some form. So we do free training for 3D printing and 4-hour and 5-hour training, exposure, etc. And then we're now slowly moving into curriculum integration, which I think is important in terms of the sustainability. So we've experimented by teaching BSc honors students 3D printing over a course of the semester and set them a project, and they were actually tested in their exam on 3D printing, and then they could then use that skill to come back and develop products that they wanted. So curriculum integration is important, but again, in a traditional environment, you face a number of challenges there. But we are experimenting with that and trying to include trainings within the curriculum. And then in terms of perhaps some of the projects, so just very quickly, we've had students work on drone delivery projects, build their own kind of system to deliver small packages, using even AI included in the software to basically streamline their design. This was an interesting project that we had as well, with the students developing their own smartwatch. And they kind of fused a Tamagotchi, if you guys remember Tamagotchi, with a fitness tracker, and created their own character that the more you exercise, the fitter you kind of keep this character. And it was quite cool. They also entered a competition, and I think they won a prize with it. So these are engineering students, so they're making the time to actually develop these side projects. And then we had some of our colleagues that are even on our African Makerspace group work on the Loco AUV, so the low-cost underwater vehicle, which has been an ongoing project at the lab. And these pictures are actually from the build sessions, in the lab and at another venue, which has been quite fulfilling. And again, it's all about collaborating. So we have Moketsi and them from Ocean Hub. We have David as well lending his support. We have a master's student, Emmanuel, also working on this. We've got multiple people on the group that are contributing their expertise. There's even some international experts that are contributing. So the key being collaboration to get a lot of these projects done. And there are some other projects, but I'm probably just going to skip ahead in terms of time. And if we have time, we can come back to it, because I think what's important is in terms of the challenges that you face in a makerspace in higher education. And I think this is important, and there's some learnings from this. The biggest challenge, I'm sure most of you will be familiar with, is the traditional university model is a very siloed mentality. It's very policy driven. There's no sort of flexibility in it. And that has served as a good model for research, over the past 50 years, 100 years, in terms of the fact that every department has their own research lab, and they build what they're good at, and they carry on. And unfortunately, that doesn't work for the makerspace environment, because it's quite a dynamic environment. It relies on collaboration. It relies on experts in different industries working together, rather than only looking at how can it benefit them and their department. And then you also have collaboration, and collaboration within the university environment, if it's not driven by curriculum-based activities, it can be quite challenging. So generally, makerspaces fall outside of the general curriculum. And what tends to happen is, because this is not linked to anyone's KPIs, their time is obviously occupied with their current work, and it's very difficult to get time to collaborate, even if they want to. And then similarly, you have time, student time and staff time. So student time, especially since everything is driven by the curriculum. And if you look at the built environment, engineering and the built environment, students are in lectures from 8 to 4, or lectures in the morning and then tutorials in the afternoon. There's not much space within their curriculum, or not much time for them to actually spend in the makerspace. And similarly for staff, because they have other responsibilities. So how do they find the time to actually experiment, even if they want to? And then, in terms of funding, that's always a issue with makerspaces, and that's a challenge even in higher education, especially with, generally speaking, in the current context and climate in higher education, even in South Africa, austerity measures and money being channeled through to maintenance and to curriculum work and everything else in the running of the universities. There's not much funding available internally to prioritize non-curriculum based labs. And one of the major challenges as well, which I've experienced recently, is intellectual property, especially in higher education, because you've got undergraduate students and rules that apply to them, postgraduate students and rules that apply to them, staff and research staff and a different set of rules. And in South Africa, this is obviously regulated by the actual intellectual property laws. So it's quite a complicated thing to work with. However, we are actually working towards developing a roadmap or a decision tree to help us with this, because generally speaking, there hasn't been a lot of development in that area, because a lot of the research and a lot of the innovation has happened at, as I mentioned, the higher levels and from research labs, which a different set of intellectual property rules govern. And in terms of maybe looking at this and trying to suggest what would be some of the ways that we've tried to tackle this. One thing in terms of the traditional university model is actually the proof of concept of a makerspace in higher education, and the projects that are coming out actually give you sort of a tangible or a leg to stand on, if I were to put it that way. And that's been our lab's been in existence for about 2.5 years, and majority of our time has spent on building projects so that we have a proof of concept to say that this pipeline actually works, and that we actually are getting projects that are coming out, students are benefiting, there's some commercialization, there's actual proof of concept. And that does help in terms of slowly breaking down this traditional model that the university has. And then in terms of policy, finally, in terms of UCT, and the South African government has also started placing a lot of emphasis on innovation and especially innovation at universities. And this has now become a focus even at UCT, where they're trying to develop their own sort of makerspace ecosystem, or what they call, I think it's called the Innovation District, which is a much larger project where they want to create a large number of labs that are in a centralized area, which can actually push for innovation. And so I've tried my best to influence policy and get involved in these discussions and promote the fact that makerspaces have been doing this for a long time, and you need to look at makerspaces and start there, because as you build through the makerspaces, you will naturally graduate to innovative ideas as well as commercialization. And then there's the sort of breaking down barriers, which unfortunately requires a lot of knocking on doors and a lot of work on your part to actually try and garner support at the university. And in terms of collaboration, one of the things is to effectively develop a network of like-minded individuals. Sometimes with the lab, you can obviously see the benefits and you want everyone to benefit, but not everyone would have the time and not everyone has a similar mindset. So finding those like-minded individuals is key, and developing from there and demonstrating the value of collaboration, which it's sometimes quite obvious to us. So for example, if I have a problem and I know Joseph is an expert in that coding and that particular area, it's always easier to reach out to a colleague and ask them, rather than spending 2 weeks on a problem and breaking your head on a piece of code that you can't get working. It's always easier to collaborate and work with someone else who has the necessary experience, and demonstrating that value through multidisciplinary projects does help. And then in terms of time with students and staff, we've tried to be as flexible as possible within the makerspace. So sometimes we work till 8:30 at night. On the local project, it was quite fun. We had build days where we started sometimes at 2 o'clock and we finished at 8:30 at night, with all of us there in the lab, just building, making, and going crazy. So being flexible with the makerspace, with times, by initially, allowing after hours access and building these projects has helped. And also we're trying to get it into the curriculum in some way or form. And then with staff, we're also trying to encourage staff training and staff development within the makerspace so that they can also have access. And then when it comes to funding, the question mark is there because I don't have the solution for that, but I'm sure there's far more experienced people on this call at the moment. But we have experimented with trying to obviously raise our own funds. We're working with external clients and companies. We've got some projects where the rollout would be in conjunction with external companies where they will pay for a certain amount of training, or in terms of some projects, we get funding from RCNI or the university where, for a project. And because we part of that development, we make a bit of money through that project. So there's various mechanisms that we're trying to work with. And thankfully, we don't necessarily have to abide by the traditional sort of university regulations because of by being a makerspace. And then intellectual property, we're trying to address this through the development and expanding, of the current IP model to work within the makerspace and to also have a roadmap for students and staff members, so especially users, because the most common question I get asked by students is they come in, they say, I have an idea, but I don't know if I can share it with you because you may steal it. I'm worried someone's going to steal it. So how do we deal with IP? How do we deal with the protecting of ideas? Obviously, this doesn't mean that we don't support open sourcing. This is obviously because of some of the laws and regulations of the university and the country, where we need to protect some of the ideas. So some of the projects are definitely we share them, and there's no need to actually register anything. But sometimes we do need to register patents, etc. And how do we do that in the best way possible? And then in terms of, I think, support and what's required going forward is that a lot of these require institutional support. Some require individual support, so collaborating with like-minded individuals, for example. And in terms of students and staff members getting time in the space, you need curriculum support. So you can't have an engineering student being in class 8 to 5 or 8 to 4, Monday to Friday, and then expect innovation because they're so physically tired and so mentally drained from spending all this time in lectures and tutorials that they don't really have time to create. They don't have any downtime. So how do we sort of try to influence the curriculum? But that's quite challenging. So we're looking at actually allowing trainings and build sessions, etc., on weekends and after hours, which may help us. But effectively, we also need to work to get some of this within the curriculum and institutional support. And similarly, with things like funding and intellectual property, we do require, again, institutional support and external support. So with funding, it's good to partner with other labs, other companies, etc. And that's how there's access to obviously funding. And similarly with intellectual property, and there's sometimes the need for external help and external and access to lawyers, attorneys, etc., and specialists, as well as other labs. So sharing between other labs when it comes to intellectual property, when it comes to how you deal with the university model, etc. External support is definitely something that's one of the considerations. And I think in terms of some of the key learnings, which I have mentioned some of them, I think we should always place in the makerspace a student first. As a student comes in, how do we deal with them? And the makerspace itself is there to serve students and staff members and to serve the community. So and also when it comes to newer spaces like the Menzi Design Lab, you start small and you provide value instead of trying to aim for, well, in my case, instead of trying to aim for 10 or 20 projects to come out in the first year, because we had to develop the ecosystem, we focused on just getting 2 projects out within the first year and providing value. So those projects must have provide some value to society. And in this case, one of the early projects we worked on was a pothole detection device, which was a collaboration between the Radar Group and the Menzi Design Lab. And that has since gone into testing. And that obviously has societal impact if you can prevent potholes, you can prevent damage, you can prevent accidents, etc. So start small and then provide value with those projects. And then we've seen the value of having student ambassadors. So students that have come through and been trained in the lab, that have built projects, that have had, thankfully, positive experiences, they are the ones that will speak to other students about what's happening. And they will spread the message and they will grow their own group. So we actually have a group, the same guys that built the smartwatch. and the drone that work quite consistently in the lab and are sort of our unofficial student ambassadors. And then in terms of, I know it sounds cliche, but find your tribe in terms of higher education, like-minded individuals that are, that want to give their time, that are passionate in terms of student education and student contribution and growing the students and providing that expert guidance to them. It could be as simple as a professor providing a 15-minute or a 30-minute call, where they would just guide a project, for example, and do's and don'ts, or just review something. That makes a huge difference. And that value that it brings from anyone, whether it's a technician, whether it's an academic, whether it's a staff member, or even in some cases other students. So we have students that have built drones, etc., that are advising other students that are building their first drone. So those type of connections are very valuable. And the other thing I find quite helpful is, keeping an open mind when a project is presented. I've had students come to me that say that, they've presented this idea that they have to other people at the university, and they were laughed at and told that it's a crazy idea and it's not going to go anywhere, etc. So I think in the space that we are you operate, it's very important to have an open mind, and to network is very important. Network with everyone as best as possible. And again, one thing that's important that sometimes I think we don't always do is to make known what you are doing within your makerspace. And I wouldn't say advertise, but yes, to some extent advertise and market so that you can grow the space and that you can bring in more students, and you can also educate more people, have more people using the facility, etc. And I think lastly, one of the rules I try my best to abide by is to turn no user away. So regardless of how crazy the idea is, and sometimes we can't help, we don't have the infrastructure, we perhaps can't support the project, we may not have the manpower, at least sitting down, hearing the idea out, seeing how you can help, and if not, at least advising. So advising someone to take it further with a different department, with a different expert, etc. So we try to maintain that we shouldn't turn anyone away, whether they just randomly knock on our door and come through. It's always good to at least listen, and see how you can help. And I think in terms of, I'm not sure if the time is up, but in terms of some of the future goals and objectives, we looking specifically at developing this model for makerspaces in higher education, expansion, because our lab is currently about 50 square meters or 60 square meters, and then encouraging access across all faculties. And we spoke a bit about multidisciplinary collaboration and IP generation and commercialization. And the one thing we're focusing quite heavily on is student-driven innovation and research-driven innovation in terms of projects that are multidisciplinary and multi-level. So one of the examples I have there is the development of an electric vehicle, which will be both a research project where there'll be masters and doctorate students working on it and have academic supervision, as well as students working on it, undergrad students that are doing their vacation work, etc., where they will all contribute to this large project that's multifaceted, multidisciplinary, with the aim of building our own in-house electric vehicle. And lastly, but definitely not least, is I'm looking forward to collaboration with other makerspaces and other innovation hubs. And I think this is just in terms of currently where the lab sits. On the right-hand side is actually in this picture, the MDL. And then we're looking at hopefully expanding in the future to have a much larger space and area so that we can service, many more students and staff members. And I think in terms of that, I know that was a lot to take in, but that's effectively some of the shots from our lab and some of our printers. And I think if we have time, if there's any questions or comments, I'd be open to answering them. Thanks very much, Joseph. I think we've run out of time, but I hope I covered everything.
Yes, thank you very much, Yusuf. And this was just a remarkable presentation and great things that Menzi Design Lab is doing in Cape Town.
Thanks, Joseph.
For now, I think it would be nice to have a few questions. Yes, Andrew has his hand up.
Thank you, Yusuf, for your comprehensive conversation about an academic makerspace. And I'm particularly glad you were also getting into talking about intellectual property and so on. Could you say a little bit about the one thing that resonated strongly with me is when you were talking about the mechanical drawing, the manual drawing, and the
Yes.
idea that that isn't necessarily something that's provided to engineering students anymore, but that it is. I mean, I remember when I was studying engineering, I really hated the mechanical drawing classes, but they were a way of solving problems. They were a way of thinking. You know, to think about the forces involved almost as you're designing a mechanism. My question is, do, do you feel like the makerspace is in some way a remedial step for the university generally closing down some of these facilities? We've seen this in other African contexts, and in fact, universities around the world where a makerspace is set up instead of, you know, a university continuing to have normal metalworking workshops, woodworking workshops, computer labs, even. And do you think, in terms of the personnel, the HR side of things, that that is something that's viable? You know, you strike me as being a fairly unique set of skills, Yusuf, that you have. But you know, obviously, maintaining all of the staff you need for a metalworking shop and a
Mm-hmm.
manual drawing shop and a woodworking shop and all of that is going to be very expensive. Yeah, so that
Yes.
could you say something
Sure.
about where the maker spaces have this sort of role of remedial help in engineering courses to provide that
Mm-hmm.
hand stuff that's been removed from the curriculum?
Right. Okay. Thanks very much, Andrew. So I think I wouldn't say necessarily remedial, but I think it's a reaction. I think that makerspaces that are within higher education, or even not necessarily within higher education, has seen that the skills that are taught within the makerspaces, are important and have been removed from the curriculum. And I think through makerspaces, you can address that. But the challenge I think we are facing is exactly what you pointed to. The size of the makerspace, the equipment that's needed, the staffing cost, etc. So what we've also noticed is that there's, for example, if you look at architecture students, they have access to 3D printers in their architecture workshops for first year all the way through to their honors, but there isn't an actual 3D printing course that's taught to them. So they have the machines there, but if they don't have the knowledge, what's happening is the machines are consistently being used and damaged, and then they
Yeah,
kind of
yeah,
not being used. So we're looking at it in terms of where are these holes that we can sort of plug, because at the moment we don't have a facility big enough, or the manpower to physically, for example, teach manual drawing. So I think they definitely have a space to play, a role to play in higher education, but I think it needs to be on a much larger scale, in that it needs to be in collaboration with, for example, the mechanical engineering department and the civil engineering, architecture, etc. Because what tends to happen is you have all these historic labs, as you said, for metal working, etc., with lathes and even
yeah.
these machinery. And students now don't get time on a lathe. They don't weld. They don't do any of this. So how do we actually build this within the makerspace where we can get the students that are interested to come through, and they can learn over a period of time, and we can scaffold it from first year all the way through to fourth year, so when they are building their final year projects, they've got the knowledge that's necessary, rather than relying on the in-house labs.
Absolutely.
I don't know if
Thank
that
you.
answers I don't know if that
Yeah, so
answers your
it's, I
question, Andrew,
mean,
but
and then
it's
hopefully students being able to help each other out, as it almost always happens anyway.
yes,
Thank you.
and
It does, and I like the idea of it being reactive rather than simply remedial, which is a more negative take on it. If I could ask a quick follow-up question,
sure.
who pays your salary? One of the problems that the UNDP Malawi office was talking to me about is there's a point at which the Timbuktu Unipod will be handed back to the university,
Right.
but only one of the 8 staff are university staff. The salaries of the other team members
Hmm.
are coming from UNDP,
Right.
and we see this quite often where a makerspace is able to. And I've seen this in Bangladesh, other developing countries, even in the UK, where they set up the space, they have the funding to set up all the equipment, but then they don't have anyone to pay the salary. Like they don't have an ability to pay the salary, so they don't have anyone
Yes.
working there.
Sure. Sure.
How do you make your salary? Do you have to fundraise for it? Is it core
Yeah. So,
academic sort of
uh,
budgets, or is there
yeah.
some, you have to
Mhm.
bill your time to different departments across the university?
So I'm thankful for in my case, the basically this lab was actually started through the Faculty of Engineering. So the dean, the previous dean, actually motivated for it to be a permanent position. So at least the makerspace manager, which in this case is me, is a permanent position. It's a staff position. So it's similar to a technician that would be employed full time in a engineering lab. But the limitation is, and you rightly pointed out, as the lab expands, you need more people and to service the whole university, which has now proven to be the challenge because I've got to raise the funds or motivate to get someone, which will probably take a few years. So it's either through my funding and through raising funds, through projects, etc. We can pay a stipend or get, master's students or postgraduate students or undergrad students to assist and, pay them to assist as an interim measure. But in terms of my position, thankfully, it is paid as a permanent position. So I
Yeah.
think
Okay.
yeah,
Yeah.
it's very important in that in the university context to have at least the manager as a permanent person. And we're exploring a similar model with the other makerspace that we're building at UCT, where at least at minimum the makerspace manager will be someone on a who will have a permanent position, even if it's on contract for initially 3 to 5 years, and then we would train coaches and other academic leads that can come in on a part-time basis. So
Yeah,
you
and I
definitely
think that, you know, if I was making recommendations to other universities, I would actually go a little bit beyond what you said, Yusuf, to say, yes, the makerspace manager should be a salaried position,
Mhm.
and then you should, be able to bring other people in. But I would
Yes,
actually recommend that a makerspace of a reasonable size should actually have 2 staff members. One doing the technology stuff, the
yeah,
training, the
sure.
use of the machines, the maintenance, the safety, the
Mhm.
materials ordering, the procurement, blah, blah, blah. And the other one doing the business side of things. So doing the fundraising, the communications, the outreach to the schools, being part of the large grant writing opportunities, things like that.
Yes,
And I would actually go a little bit further and say if you can get 2, a technology person and a more like management person, almost like a CEO and a CTO,
yes.
then I think that can be a very winning combination for a makerspace.
Yes, yes, definitely, Andrew. And I agree. I think that should be, you're right, that should be the minimum because what tends to happen, and even in my space, and even when we're looking at planning for the other spaces, is also one technician maybe teaching a class or helping can only help a certain amount, you know? So sometimes it is necessary to have the person that may be running the space, but may also be trained in the machinery to assist so that you have 2 people on hand. And the other thing is when, the use of multiple zones within a makerspace.
Yeah,
So if
absolutely.
you have
Yeah.
someone working on 3D printing and someone on laser cutting, the technician doesn't know which direction to run in because something goes wrong on one side. He's not there to see who's almost burnt
Yeah, yeah.
themselves with the laser cutter. So it does help to have 2 people. as an initial, with room to expand.
And it also begins to help with diversity as well. So you can have a male and female member of the team, basically, which makes things easier.
Sure.
Great, thank you. Thanks for that. I'll let other people ask questions now, if there's any.
Thanks.
Thank you very much, Andrew, for your question and for getting to know more about how makerspaces work in the university. Thank you very much, Yusuf. I don't know if anyone has any further question. Is there any further question from anyone? Okay. So I think we've actually exceeded the time, but it was worth it because we've had the pleasure to listen to Yusuf on some inspiring conversation regarding the work makerspaces do in our higher education, and also getting to know especially Menzi Design Lab, the kind of things that they are doing, creating from the first stage, the basic need, to the level where those ideas can be fruitful enough for commercialization. And I would say for the fact that makerspace is really something, or makerspace is really something that is making an impact, not just in South Africa, but almost every part of the world where it is being created. So I believe there is an opportunity for us to also get to share more. I think one thing that really resonates with me concerning what you mentioned was ability to also share the things that you do with other people, get to know more ideas. Yeah. And also to collaborate with others. I believe it's something that we need to do a lot about it in terms of makerspace. So
and
thank you very
Joseph,
much.
Lionel has said in the chat that he would like to ask a question as well.
Oh, very good. So Lionel, please go ahead.
Hello. I hope everybody is doing well. Oh, thank you. Thank you for the opportunity to join to this call. I really learned a lot from the professor from Cape University. Thank you so much. When you were talking about the manual drawing, I've learned how to draw manually, but even though I've learned how to draw manually, I find it that and nowadays manual drawing we don't really use it like that. So my question is that how do you think that our university, the teacher of our university, integrating the kind of innovation solutions, and while giving a program to our students, how do you think that could motivate students that are not motivated? Kind of students that have no motivation for innovation, something like that. How do you think we could increase those students' motivations through innovation solutions while giving a program at school? How do you think that is possible?
Okay. Thanks, Lionel. So Lionel, the one aspect that you mentioned is obviously the manual drawing and its influence, and the other is you asking in terms of motivating students to be involved in innovation if they're not really motivated.
Yes.
Okay.
Right.
All right. Yeah. Okay, sure. So with the manual drawing, I think, and as Andrew alluded to, it's not only about the drawing. The ability to draw then allows you to basically map out your idea. So it could be anything, even from mapping out a business idea all the way through to designing complex parts and being able to imagine these parts, put them together in your mind and understand them, which is very important for, I think, the design phase, and before you even get to CAD. So it's very helpful all around to develop that skill. And then when it comes through to your question about motivating students, it is a challenge. especially if they're not really interested in innovation, right? But I find that you don't necessarily have to aim for innovation initially. What does help is, for example, scheduling a introduction to 3D printing course, scheduling an introduction to 4IR and 5IR, for fourth industrial revolution and fifth industrial revolution, having these sessions and workshops where you're not directly saying, hey, listen, come here and innovate and build solutions that are going to change the world, but instead you're bringing them into the lab or the makerspace by teaching them a skill or showing them what's actually happening in that industry. So, for example, we've had quite good, reasonably good turnouts with our introduction to 3D printing courses as well as introduction to 4IR and 5IR, which naturally allows you to inspire students within the makerspace, and they realize that these technologies are out there and people are doing innovative things and building products using these technologies, etc. So I find that by exposing them, educating them, and showing them the equipment and what's actually happening, you actually then start motivating them to start thinking about innovation and also thinking about community needs and social needs and how they can use the equipment, the makerspace, and resources at the university to solve these community needs. So what tends to happen is those students that come through, they're exposed to the makerspace or exposed to a lab and they see what's happening, they get to spend some time, they get to attend a workshop, etc. They tend to come back when they do have an idea or when they do want to run something by you. So I think by starting by exposing them, by teaching, by running workshops, you will inevitably create the motivation for innovation.
Oh, thank you so much, thank you so much. Now I can see that that really helped me a lot, because now I'm gonna start trying to show how community. I'm gonna bring community needs. I'm gonna show that how our community really needs the solve problems, and I think maybe that would inspire them to do the work, the things that they need at the end of it. Yeah. Thank you so
Yes,
much. Thank you.
definitely. You're welcome, Lionel. All the best.
All right.
Yes.
Thank you very much. Thank you all. And I think this is where we draw the curtains. Thank you so much, Yusuf.
Thank you very much, Joseph.
Yeah.
I
Thank you so
really
much for
appreciate it.
the time and giving us this wonderful experience concerning makerspaces in higher education. I know very well that there will be a time that we'll call upon you again to share more. And and just as I feel we still have a lot to learn from the work that you do and also to even know more about the role of makerspace.